All right, we know how to start this one, but not how to end it. So you start with a picture, hopefully, right? So boom. I mean, you guys might not be able to draw as perfect a cylinder as I, but that's okay. And the dimensions of our cylinder are the radius and the height. And we want to use the least amount of material, right? What's it say, the lightest? Oh, cool. Oh, it also doesn't have a top, so the top is open. Okay? So we want to minimize surface area. So the surface area of a cylinder, did you get this far, Judy? Cool. Is just 1 pi r squared because there's no top, and then plus 2 pi rh. Okay? Now, if we have no restrictions at all, then we can make this as light as we want by using little material, making it very tiny. Okay? But the restriction is that it has to hold 1,000 cubic centimeters. Okay? And that's a volume. So the volume, and this is our restriction, has to be 1,000, and that's pi r squared h. Okay? And remember, with optimization, we said, like normally, unlike with related rates, we're going to want to derive this surface area equation with respect to the independent variable, which means we're either going to have ds dr or ds dh. Yeah?
For the surface area equation, how are you supposed to know which one's supposed to be 2 in a row? Because if that one's just
Well, the pi r squared has to do with the circle, like the top and the bottom are the circles. That's the area of those circles.
So it's 2 pi r.
2 pi rh is the area of the side, because if you were to unroll the sides of that cylinder, it would be a big rectangle. With me? All right, well, I'll draw some pictures in a little bit and show you that, okay? But right now, that's surface area equation. And then, that's actually not even surface area. That's surface area of an open top cylinder, because there's no top. If there was a top, it'd be 2 pi r squared. So we are going to have h is 1,000 over pi r squared, right? And we're going to drop that in to our equation up here for h. Right there. Boom. And that's going to turn my surface area equation, which I'm just going to call S, into pi r squared plus 2 pi r times 1,000 over pi r squared. And it cancels out. This simplifies down a pretty good amount. So we're going to have pi r squared plus 2,000 over r. Did we get here?
Yeah.
Okay. Some of us did?
Yeah.
Oh, what just happened there? So this stylus has been acting funny. 2,000 over r. Over r. All right. So now we got it down to a single independent variable, unlike related rates, in which we can have many independent variables. Okay. Here we just need one. We're going to derive it. So we're going to get ds dr, and that's going to be the power rule here, 2 pi r, and really the power rule here on the second one because it's r to the negative 1. So you get 2,000 over r squared, negative 2,000 over r squared. All right. And this is similar. We've done a cylinder one before. We need to get a common denominator, and that's going to be r squared. So if you were to put this over r squared, that would make the numerator 2 pi r cubed. So you okay over there? What was that noise?
Yeah, I got it.
So it's 2 pi r cubed minus 2,000 over r squared. Okay? And now we need to know where that's 0. Cool. Well, it turns out that if you solve the numerator for 0, you're going to do 2,000 divided by 2 pi, and then take the cubed root of that. So that's going to happen when r is 10 over the cubed root of pi. Okay, because the cubed root of 1,000 is 10, and there's a pi in the denominator. And then we're going to make our little number line to show that that's a minimum. So the smallest r can be is 0. The critical value is 10 over the cubed root of pi, which I don't know what that is, but that's fine. And there is no maximum on r. And then we test these intervals. If we go back up to our derivative, just think about this. We need to plug in a number that's less than 10 over the cubed root of pi. I don't know what number that is. So I'm going to plug in something really close to 0, 0.00001. Okay? If you plug in a super duper tiny number into 2 pi r cubed, you're going to get a super duper tiny number. Minus 2,000 is going to be negative. And then divided by r squared is positive, so negative divided by positive is a negative. If you plug in a really big number, you're going to get positive. And that shows that the surface area equation is decreasing and then increasing, and it changes at 10 over the cubed root of pi. And since this question is asking for what are the dimensions, we just need to tell them what r and h are. So r is going to be 10 over the cubed root of pi, and then we'll come back up here to what h is. So the dimensions are that we want r to be 10 over the cubed root of pi centimeters. And the height, if you plug that in, you're going to get 1,000 over pi time, and this is just ridiculous, but we can simplify this down a little bit. We're going to square that number, okay? So we're going to get 100, because that's 10 squared, over pi to what power? The cubed root makes it to what power? To the 1/3, and then we're squaring it, so it's to the 2/3. Okay? That's a 100. All right, and then look, we can reduce that because in the denominator we have a pi and then a pi to the 2/3 in the denominator of the denominator. So what's pi over pi to the 2/3 going to become?
Cube root of pi.
Yeah, it's the cube root of pi or pi to the 1/3. Okay, so that's what's in the denominator, pi to the 1/3. And in the numerator you have 1,000 divided by 100, so that's 10. So it turns out that r and h are the same exact thing. Crazy, right? I know, right? Okay.